Hello, my dear students. Welcome to the e-learning class from Nirmala High School. Today, let's learn some of the basic concepts of the chapter Electricity. Dear children, we all know that we are dependent on electricity in such a way that it has become part and parcel of our lives. Then, what do you mean by electricity? Electricity is the presence or the flow of charge in a conductor. You all know that conductors are the materials that allow the flow of electric charges to pass through them. Then, what do you mean by charge? Charge, it is a property of atom. So you will all know atom consists of protons, neutrons and electrons. So charge is nothing but it is a property of atom. It may be positive or negative. So positive is represented with the plus sign and negative with a minus sign. Then the third point is like charges repel each other and unlike charges attract each other. So if we take an example of magnet, here I have taken two bar magnets. So we all know magnet has two ends. So one is called as a north pole, the other side will be south pole. If I bring two north pole together or two south pole together, then they will repel each other. Or if I take north pole of one bar magnet towards the south pole of another bar magnet, then they will attract each other. What it indicating, children? It indicates that like poles always repel each other. See here in this example, if I bring two positive charges, they will move apart. They are repelling each other. In the same way, if I bring the two opposite charges, if I bring positive and negative charges together, then they will attract each other. Then how do we represent charge? We represent charge with a capital Q and its SI unit is coulomb. So the coulomb is represented by the letter C. Children, now let us understand more about charge. We all know that atom consists of electrons, protons and neutrons. Electrons are negatively charged, protons are positively charged, then neutrons are not having any charge. Then what will be a charge on one electron? As I've said, so the charge on one electron will be represented with the small letter E. The charge is nothing but it is minus 1.6 into 10 to the power of minus 19 coulomb. As I've said, charge is having a unit of coulomb which is represented by the letter capital C. Then what will be the charge on one proton, children? Since proton is positively charged, so instead of the negative charge, so proton charge will be plus 1.6 into 10 to the power of minus 19 coulomb. Then how do we calculate the number of electrons in 1 coulomb of charge? In your textbook, they have given that number of electrons in 1 coulomb of charge is nearly equal to 6 into 10 to the power of 18. How can we calculate that value, children? So we have a relation here. Q is equal to N into E. What do you mean by Q? Q is charge. N is the number of electrons. As I have said, E is a letter where you represent charge on one electron. So I can rewrite this relation, that is Q is equal to NE, as N is equal to Q by E. So here I need to calculate the number of electrons in 1 coulomb of charge. That means what will be the charge? 1 coulomb. So therefore Q value will be 1. And what will be the E value? Minus 1.6 into 10 to the power of minus 19 coulomb. If we substitute that value, so that is 1 divided by minus 1.6 into 10 to the power of minus 19 coulomb, then the number of electrons we are going to get as N is equal to 6.25 into 10 to the power of 18. This is the exact value what we are going to get if we calculate it. You may be wondering because Here in this formula, I have said that electron is a negative charge, isn't it? While calculating the number of electrons, here I did not represent it with minus sign. Remember, number of electrons cannot be negative. Understood, children? Next, let's learn more about electricity. Electricity can be classified as static electricity as well as current electricity. In this chapter, we are going to learn more about current electricity. Already you have learned static electricity in your previous classes. As the name itself suggests, static. That means the one which is not moving. Understood, children? So here I have been given with few examples. In all the examples you can observe there is a comb, isn't it? So if you take a comb and rub it against your hair and just bring it to the like a piece of papers, then that piece of papers are being attracted by the comb. Why it is so, children? I think most of you have already done this activity. So you can use your scale also instead of comb. If you just rub the plastic scale just across your hair and just bring it near the paper pieces, then those paper pieces are attracted by the scale also. It is because in this figure you can observe when you just rub it against the hair, then they will produce static charges. As the name suggests, these charges will not move. So when it has been held near the paper pieces, then the paper pieces will attain the opposite charges. So therefore, they attract each other. Then let's learn about what is current electricity. Here in this figure, I have got a tube light which are connected by the copper or aluminium wire. Here you can see that the charges are flowing. They are not static. If the charges are continuously flowing through a conductor, then it will produce electric current. Now let's learn about what is that electric current is. As I've said, here I have considered, say, a metallic conductor. You can observe that electrons are free electrons and they are moving electrons. Because of the movement of these electrons, the charges are moving, therefore the current is produced. So I can define the current as it is a flow of charge per unit time. If I consider 1 unit time, then what will be the number of charges that is flowing from one end of the conductor to the another end. Then the current is represented by the letter capital I. We have a relation here, current is equal to charge by time. So as I have said, current is represented by the letter I and charge is represented by Q. Then time is represented by T. Then what will be the SI unit of current? SI unit of current is ampere. It has been named after a scientist. So that is John Mary Ampere. So the ampere unit is represented by capital letter A. If you want to calculate or measure the big amount of current, then we have to represent it with the unit milliampere, that is small m a. As we calculate the distance, short distance we calculate it in meter. If it is more, then we go for kilometer. Like in the same way, here if the large amount of current has to be represented, then that unit will be milliampere. Milli in the sense 10 to the power of minus 3 ampere. So milliampere will be represented by the letter small m into A. If you want to calculate small amount of current, then the unit will be represented as microamperes. See, this symbol is representing micro. Okay, microampere. So that is represented by the letter mu. Okay, it is just looking like m in between m and u. So that is why it's called as mu. It is a Greek letter. And 1 microampere is equal to 10 to the power of minus 6 ampere. Then how do we calculate this current? Is there any device to calculate the current? Yes, we have. The current is measured by the device called as ammeter. Now, let's learn more about the device ammeter. So here I have got the ammeter, children. So the ammeter will have the readings like this from 0 to 10. And here I have got two knobs, isn't it, children? So the red one is representing the positive and the black knob is representing the negative end. So now let us see the properties of an ammeter. It has low resistance. So what do you mean by low resistance, children? It is a property of a conductor to apply or resist the flow of charges through it. You're going to learn more about this resistance in the further classes. Now, then the second property is it is always connected in series. Okay, it is always connected in series. Now, here I have got a simple circuit. I hope all of you have already learned the some of the uh, electric appliances which are represented with the symbols. This is a bulb, this is a plug key, and it is a cell or a battery. Now, since I have said ammeter has to be connected in series, see here the positive end of the battery is connected to the positive end of the ammeter and the negative end of the battery is connected to the negative end of the ammeter. So that is, it is series with respect to the bulb. Okay. Then let me take the example of a metallic wire. As I've said, the electrons are free and they are moving. They are not static. When I say electrons are moving, then the electrons are moving randomly. There is no unidirection. That means one electron is moving in this direction, another electron may move in different direction. That means there is no uniformity in the movement of the electrons. Let us understand this situation by taking one example, children. Here I have got two beakers, say beaker A and beaker B, which are connected through the one of the pipe. Okay. After that, let me fill both the beakers with the same amount of water. Now, my question is, when I fill both the beaker with the same amount of water, will the water flow from A to B or B to A? Yes, you're telling the answer no. Because since both the beakers are having the same amount of water, there is no question of moving water or flowing of water from beaker A or beaker B or from beaker B to A. That is the same condition here also. Since I have got the same set of electrons on either side of the metallic wire, then there will not be movement of the electron in a single direction. What I need to do is I have to create a difference. How to create a difference? Let me take the same example of the beaker. See here, children. Here what I did is earlier I took same amount of water. Now in the beaker B I have reduced the amount of water. Okay, so I have taken a little amount of water. Then what will happen now? Yes, your guessing is correct. The water will move from the beaker A to beaker B, isn't it? So that is, we have created this difference. So this amount of water is not there in B. Therefore, the water will flow from beaker A to beaker B. So till when it starts moving? So it will move until the amount of water in both the beakers are equalized. So understood? So in the same way, we can create difference even in the metallic conductor. How to create a difference, children? By connecting it to the cell or a battery. Just observe, as I've said, the metallic conductor are having the free electrons. As I've said, electrons are negatively charged. Since they are negatively charged, as I've said, unlike poles attract each other. As I connected this end of the metallic pipe or the wire with the positive end of the battery, the negative charges will be attracted by the positive end of the battery. Similarly, the other end is connected to the negative end of the battery. these electrons, negative to negative, will repel each other. So what these electrons will do now? These electrons also will follow the other electrons so that they will be attracted to the positive end. All the electrons will move in a single direction now. That means we have created a difference by connecting it to the cell or battery. That means this is about the potential difference. What is potential difference, children? Potential difference is nothing but work done to move a unit charge from one place to another. So potential difference is represented by the capital letter V. How do we calculate the potential difference? Potential difference is equal to work by charge. So that is V is equal to W by Q. W means work, Q means charge. What is the SI unit of work? It is joules. What is the SI unit of charge? It is coulomb. So therefore, joule by coulomb is nothing but it is represented by volt. So therefore, SI unit of potential difference is called as volt. So that is represented by the letter V. Then how do we define 1 volt, children? 1 volt is nothing but. So when do we say that 1 volt of potential difference has been created? When 1 joule work is done in carrying 1 coulomb of charge, then the potential difference is called 1 volt. As I have said, when the work done is 1 joule and when the charge is 1 coulomb, then we can say that 1 volt of potential difference is created. Then cell or a battery are the devices to maintain the potential difference. So we need a cell or a battery to create the potential barrier. Then how do we calculate the potential difference, children? Potential difference is measured by the device that is voltmeter. So then what do you mean by voltmeter? Voltmeter so has a property of high resistance. As I've said, we are going to learn more about high resistance. It always connected in parallel. So where we saw about the ammeter where it was connected in series, whereas voltmeter is connected in parallel. Then if we take a simple circuit having a cell, plug key and a bulb, remember the voltmeter is connected parallel to the bulb. So here positive end of the battery is connected to the positive end of the voltmeter, negative end of the battery is connected to the negative end of the voltmeter. Then remember, current always flow from higher potential to lower potential. As I've said with the example of a beaker, so always the current will flow from higher potential to lower potential. I hope you have understood all the concepts what I have dealt today, children. It is the time to take down the homework. So we have got the questions in the page number 94 and 96, children. So the question number 1, 2, 3 in page number 94 and question number 1, 2, 3 in the page number 96. Please write those questions in your notebook as well as in A4 sheet. I hope today you have enjoyed the class.